You know, our digital world is expanding like crazy, but so is its footprint right here on Earth. So today, we're going to look at a pretty radical idea. What if we moved our entire digital infrastructure into space? Is this humanity's brilliant next chapter, or are we about to build an inescapable trap for ourselves? Let's break down the promise and the serious peril of the orbital cloud.
Let's just start with one number. Get this, 4%. That's how much of all the electricity in the US is already being guzzled by data centers. And with the AI boom just taking off, that number's on track to more than double by 2030. This hunger for power is becoming a massive problem.
So that leads to a pretty wild question, right? If our planet is struggling to power our digital lives, what if we just looked up? What if the real solution isn't on the ground at all, but waiting for us up in orbit?
Now, for decades, this whole idea was pure science fiction. The reason was simple: cost. It was just astronomically expensive to get anything into space. But that is changing, and man, is it changing fast.
The scale of this price drop is just insane. It's the real game changer here. The space shuttle, it cost about $16,000 just to lift a single kilogram. Then SpaceX comes along with a Falcon 9 and drops it to around $2,500. But look at the goal for Starship. They're aiming for $100 per kilogram. This isn't just a little bit better. This completely rewrites the rules for what's possible in space.
This quote really nails the new reality. As space journalist Eric Berger says, we're entering a world where getting to orbit just isn't the hard part anymore. And that one shift takes ideas that used to be impossible and suddenly makes them feel, well, almost inevitable.
Okay, so if getting to space is cheap, what can we do with that? Well, one of the most ambitious ideas out there is to build our next-generation digital world, not in some server farm on the ground, but up in low Earth orbit. Let's take a look at what that actually means. The concept is called the orbital cloud. I want you to just picture this: entire constellations of satellites that aren't just for GPS, but are actually full-blown data centers, crunching away on massive AI workloads, all running completely off the Earth's grid.
But why go through all that trouble? Well, the advantages are huge. First off, in space, you have unlimited solar power, 24/7. No more relying on power plants. Second, the vacuum of space is the perfect free cooling system that gets rid of the insane amounts of energy and water we use just to keep data centers from overheating on Earth. Some companies are even talking about using the moon as the ultimate secure data vault, far away from any earthly disasters. And maybe the biggest deal of all, this could create a truly global internet that can't be censored, which would change everything about access to information.
So how does all this stuff talk to each other? We're talking about a major upgrade from the old school radio signals. This new network would use lasers. And to give you some perspective, NASA says it's basically like going from a clunky old dial-up connection to blazing fast fiber optic internet. A map of Mars that would take 9 weeks to send with radio waves, with lasers, it could be done in just 9 days.
It all sounds like a perfect, clean, high-tech future, doesn't it? But there's a massive problem that we've been creating for over 60 years. A problem that threatens to make this entire vision, and maybe even space itself, completely useless.
This is what low Earth orbit actually looks like. It's not that beautiful, empty space you see in the movies. It is a junkyard. For decades, every single launch, every satellite deployment, every accident has left a piece of trash behind. And that trash, it doesn't go away.
Let's talk some numbers. NASA estimates there are around 500,000 pieces of junk up there the size of a marble or larger. Now, a marble doesn't sound so bad, right? But when that marble is traveling at over 17,000 miles per hour, an impact isn't just bad, it's catastrophic. And the worst part? These things are too small to be reliably tracked.
And yeah, it gets worse. There are over 20,000 objects that are the size of a softball or bigger. These are the ones we can track, the ones that the International Space Station and our active satellites have to constantly dodge. Every single one is a mission-killing bullet just waiting to hit something.
What makes this so incredibly dangerous isn't just the sheer amount of junk. It's the fact that this is not a static problem. It's a chain reaction just waiting to happen. One single collision can make the situation exponentially worse for everyone, forever.
This nightmare scenario actually has a name. It's called the Kessler syndrome. A NASA scientist named Donald Kessler proposed it way back in 1978. The idea is that once orbit gets crowded enough, a single collision will create a cloud of new debris. That cloud makes more collisions more likely, which creates even more debris, and on and on. It's a runaway cascade that could basically trap us on Earth surrounded by a shell of our own garbage.
And if you think this all just sounds like a theory, it's not. It has happened. In 2009, a working American Iridium satellite and an old, dead Russian Cosmos satellite slammed right into each other. It was a hypervelocity crash that instantly created thousands of new, large pieces of trackable junk, and probably millions of smaller, untrackable fragments.
This NASA chart shows you exactly what happened next. The debris from that one event didn't stay put. It spread out, polluting a massive, critical region of orbit. That single collision back in 2009 is still one of the biggest single sources of dangerous space junk up there today.
So this brings us to the heart of the problem. We are in a race. On one hand, we're building this incredible future in space faster than ever. On the other, the mess we've already made threatens to bring it all crashing down before we even really get started. The good news is, some brilliant people are working on solutions, and some of the ideas are pretty wild. One concept uses these long electric tethers that create drag as they move through Earth's magnetic field, literally pulling junk out of orbit. Another idea is something called a momentum tether that would basically grab a piece of debris, swing it around, and then just fling it back into the atmosphere to burn up. So we're developing the tech to clean up our mess, but the scale of the challenge is just enormous. So you have these two paths in front of us. The orbital cloud represents a future of limitless energy and information. But the Kessler syndrome represents a future where we're trapped on our own planet by a shell of our own making. We have the technology for both of these futures. So the only real question is, which one are we going to choose? Are we going to learn from the mistakes we've made down here on Earth, or are we destined to just go up there and pollute our final frontier?